Hello to all dear students. In this video we'll be discussing about another topic of data graphics, that is scatter plot. You can also call it as scatter diagram. So starting with an introduction. A scatter plot is a graph showing the relationship between two variables. The variables are plotted on a coordinate grid and the points are connected with a line. Scatter plots are sometimes called as scattergrams or XY plots. These are used to show how one variable affects another. See, as you can see, it is also known as XY plot. So you can see there are two variables. So therefore it is also known as bivariates. And here this plot is basically drawn with two variables, and among these two variables the first one is independent variable and another one will be dependent variable. A scatter plot or a scatter diagram, it is a simple and attractive method of diagrammatic representation of a bivariate distribution to determine the nature of correlation between the variables. So as you can see, bivariate distribution means here we are basically checking out the distribution of bivariates, means two variables. Next, it is the simple method of studying the relationship between two variables without calculating any numerical values. Okay, so as I have told you, here it is a plot for bivariates, means where two variables are being used, and among these two variables one will be the independent variable and another one will be the dependent variable. And since this is a graphical representation, you should know that independent variable is basically plotted on the x-axis and dependent variable is plotted on y-axis. The scatter diagram is used to find the correlation between the two variables, that is the independent and the dependent variable. This diagram helps you to determine how closely these two variables are related. And after determining the correlation between the two variables, you can then predict the behavior of the dependent variable based on the measure of the independent variable. Fine. Next, we should check out some of the terminologies that you might be coming across in this scatter diagram. The very first thing is correlation, that is when the two sets of data are linked together. Here co means together. So you are basically determining the relationship between the two variables, how related these two variables are. Next, bivariate data means, as I have told you, a setup of data made up of two variables. For example, comparing height to weight. So here basically as the height increases, the weight also increases, isn't it? So over here height will be the independent variable and weight will be the dependent variable. Next, line of best fit means to find the direction of a correlation between two variables, means whether it is an uphill or a downhill, you will get to know. And lastly, trend line means a line on a graph indicating a statistical trend. So now we should know how to draw a scatter plot. Plot the values of the variables x and y along the x-axis and y-axis respectively. Show the values of the two variables by dots on the graph. Each dot represents a pair of value. Okay, so basically here what you are doing in the scatter plot or a scatter diagram, you are just making dots. Okay, and this dot represents the value of x-axis as well as the values of the y-axis. Here we don't need to draw a line. Okay, no need of connecting the dots, just you need to make dots, that's it. Just for an example, the local ice cream shop keeps track of how much ice cream they sell versus the noon temperature on that day. Here are their figures for the last 12 days. So these all are the figures. So this is the temperature versus the ice cream sales. Now you only say when you will consume more amount of ice cream, at hot temperature or in cold temperature. Obviously in the hot temperature, isn't it? So we should check out the relationship. Here temperature and ice cream sale is there. So what might be the independent variable and what is the dependent variable? Yes, obviously temperature is the independent variable. Depending upon the temperature, we will consume more or less amount of ice cream, isn't it? So you might be knowing in the hot climate you will be consuming more ice cream, and in the cold weather you will be consuming less ice cream, isn't it? So the ice cream consumption mainly depend upon the temperature. So here temperature will be the independent variable and ice cream sale will be the dependent variable. So that means temperature will be going to the x-axis and ice cream sales will be plotting on the y-axis. So this is how the scatter plot will be looking. So how you can see, on the x-axis will be the temperature in degrees Celsius, and on the y-axis will be the ice cream sale. So here you can see, as the temperature increases, the ice cream sale also increases, isn't it? Isn't it? Yes. Now just for example, at temperature 14.2, so 14.2 means somewhere over here. This point is for 14.2, isn't it? This one is 14.2 is the temperature, and ice cream sale is $215. So somewhere over here it will be 215. So basically this very point, it will show the level of x-axis and y-axis. No need of connecting like this, no need of connecting, just you need to make points, that's it. So this is the scatter diagram, and what it is showing, it is showing the relationship between the temperature and the ice cream sale. And you got to know, as the temperature increases, see this is 5, this is 10 degrees, 15, 20 degree, 25 degree, isn't it? So as the temperature increases, this ice cream sale also increases. So this is a kind of uphill graph. Okay, so this is how you will get to know the relationship between two variables, isn't it? Next we should check out the interpretation of scatter diagram. So first one is perfect positive correlation. Here, if all the points of scatter diagram fall on a straight line with positive slope, then the correlation is said to be a perfectly positive. R is equals to +1. R, we are using R to determine correlation. Okay, correlation means we can write R. So you can see a curve somewhat like this. So what you can find over here, a positive correlation means if the x coordinates and the y coordinates both increases, then it is the positive correlation. This means that both are going up and they are related. Okay, so this is a positive correlation. And if all the lines are falling on the straight line, like over here, like this, so this is known as a positive correlation. Fine. Now we'll have an example. If you look at the age of a child and the child's height, you will find that as the child gets older, the child gets taller, isn't it? Because both are going up, it is a positive correlation. Like for example, age, at the age of 1, the height might be 25 inches. At age of 2 years, the height will be 31 inches. At the age of 3 years, the height will be 34 inches, and so on and so forth. Okay, so as you can see, as the age is increasing, the height is also increasing. So both are increasing. So this is known as a positive correlation. Okay, so both age as well as height, both the values on the x-axis as well as the variable on the y-axis, both are increasing. So this is known as a positive correlation. You can see it is a kind of uphill. Next, when there is a positive correlation, the second will be the negative correlation. So first of all, what is a perfect negative correlation? If all the points of the scatter diagram fall on a straight line with negative slope, then the correlation is said to be a perfectly negative, that is R equals to -1. You will have a scatter diagram somewhat like this. So each and every point is on the straight line. So this is known as perfect negative correlation. Okay, so this is perfect negative, not negative correlation. This is perfect negative correlation. Now you should know what is negative correlation. Means if the x coordinates and y coordinates have one increasing and one decreasing values, then it is a negative correlation. This means that one is going up and one is going down, making a downhill graph. This means the two variables are related as opposites. Fine. So this is a negative correlation. We'll have a example over here. If you look at the age of your family car and its value, you will find as the car gets older, the car is worthless. This is a negative correlation. And you know this thing very well. Okay, so as the car gets older and older, its sale price, its resale price will be reducing, isn't it? So car, when you purchase car and after 1 year its price will be $30,000, in second year its price will be $27,000, and so on and so forth. So as the age of the car increases, its value, its resale value will be reducing. So you will find somewhat like this, a downhill curve. So this is known as a negative correlation. Now there is one more thing known as no correlation. If the points are scattered in a haphazard manner, then it is a case of zero or no correlation. Okay, so you cannot say whether it is a uphill curve or a downhill graph. You cannot say, okay, because here the points are scattered. If there seems to be no pattern and the points looked scattered, then we call it as a no correlation. This means the two are not related. So in this type of a scatter diagram, data points are spread so randomly that you cannot draw any line through them. So in this case, you can say that there is no relation between these two variables. A simple example is, if you look at the shoe size of baseball player and their batting average, you will find that the shoe size does not make the player better or worse. Then they are not related. So this is no correlation. We cannot say that if the shoe size is more, then the baseball player is more talented player. We cannot say like this. So there is no relationship between the talent of playing baseball and the shoe size of the player. So we call it as a no correlation. Next important thing is a strong correlation. We know about positive correlation, negative correlation, and no correlation. Another important thing is a strong correlation. In this diagram or in this scatter diagram, data points are grouped very close to each other such that you can draw a line by following their pattern, somewhat like this. So here you can see all the data points are so much close to one another, means they are very much close to the line, to the trend line. Okay, so this is known as a strong correlation. Now when there is a strong correlation, obviously there might be a weak correlation which is opposite of the strong correlation. So in this type of scatter diagram, data points are little closer together and you can feel that some kind of relation exists between these two variables. So somewhat like this. Here you can see the data points are scattered, means not kind of no correlation, there is relation, because you can see as the x-axis increases, the value of the y-axis is decreasing, isn't it? It is a kind of negative correlation. It is a kind of negative correlation, but the data points are not nearby to the trending line. So this is known as a weak correlation. Now, these scatter diagram, these are unitless. They mainly ranges between -1 and +1. The closer to -1, the stronger the negative linear relation. The closer to +1, the stronger the positive linear relation, and the closer to 0, the weaker any positive linear relation. So in this diagram you can see all the data points are close to the trending line, isn't it? So we call it as a strong positive correlation. Okay, plus R, that is strong plus R, means it is a strong positive correlation. The value of correlation will be +1. Similarly, this second graph, here you can say this is also kind of positive correlation, but it is a kind of weaker correlation, means the value will be less than +1. In between +1 and -1, means it will be more than 1, but it is less than plus 1. So once it can be plus 0.9 or plus 0.5 plus 0.2, you can say. So that is weak correlation, means it won't be plus 1 but less than plus 1. So in these two graph you can see both are positive correlation, but the above one is a strong positive correlation because here the data points are closer to the trending line, whereas the below graph, here is also a kind of positive correlation, but it is a weak positive correlation because the data points are little bit away from the trending line, but it is going uphill. So both are positive correlation, but one is strong and another one is a weaker correlation. Similarly over here, it is a kind of negative correlation, and that too a very strong correlation, very strong negative correlation. So here the value of R is equals to -1. Next, here it is also kind of negative correlation, but it is a kind of weaker negative correlation because the data points are away, little bit away from the trending line, but it is going downhill. So here you can expect the value of R is equals to maybe -0.3, -0.1, somewhat like this. Okay, so these are the various correlation. Next, we should check out some of the benefits of the scatter diagram. A scatter plot is a great way to visualize data sets with many variables. There are many advantages of using scatter plots to analyze data besides being quick and easy to make. So all the benefits basically includes, it shows the relationship between two variables. It is the best method to show a non-linear pattern. How to show the non-linear pattern? The range of data flow, that is maximum and minimum value, can be easily determined. Observation and reading is straightforward, means you can say, means it basically show if there is a relationship between two variables or not. They can show the direction of the relationship as well, and even they can be used to make predictions also. Lastly, plotting the diagram is relatively simple. So these all are the benefits of a scatter diagram. Next, we shall check out some of the limitations, some of the disadvantages of a scatter diagram. See, while scatter diagram have many advantages, there are some disadvantages of using these scatter diagrams. So these are, scatter diagram are unable to give you the exact extent of correlation. Scatter diagram does not show you the quantitative measure of a relationship between the variables. It only shows the quantitative expression of the quantitative changes. Lastly, this chart does not show you the relationship for more than two variables. Okay, so this you can use only for bivariates, means for understanding the relationship between two variables and not more than two. Right? So these all are the limitations of a scatter diagram, and this was all about today's video regarding a scatter diagram. I hope you people found this video helpful. Thank you for watching.